welcome you to today's lecture. What we left last time, we discussed three important concepts: probability, and we start with outcomes. Then we discussed sample space. After that, we discussed event, and lastly, we discussed event space. So the main idea about all these concepts is basically from set theory, and we say that we can combine these two if this is set theory and this is our probability terminology. We can say that if we say sample space, we mean universal set. If we say outcome, that's we mean element of a set. So lastly we discuss event, that is a set. Yeah. So this is the basic idea mathematically that we get from the set theory. After that we discuss event space, and with the help of an event space we use a theorem here. Theorem was 1.2, and theorem says that for an event space B, which is based on B1, B2 and so on, okay, and any event A in the sample space, okay. So let Ci is equal to A intersection Bi, okay. So for all I is not equal to J, the event Ci and Cj are mutually exclusive. And A is actually equal to combination of C1 union C2 union so. So this is the theorem that we discuss, which is actually using the event space. Now we want to look at using graphically. So we consider a universal set here, a rectangle, and an event A here. So we consider the same universal set, but we partition it or divide it into event space, that is B1, B2, B3 and B4. These are events. We combine these events, we can call it event space, and we take the intersection between A and B. So if I do that, what I get C1, C2, 3 and 4. So this is the basic idea that tell us if you take the intersection of an event with an event set, event space, then you get the same event. Okay, so now if we look at this figure, this actually explains that P is a subset of B1, B2. This is actually an event space of these events B1, B2, B3 and B4, and Ci is actually equal to A intersection Pi, where I is from 1 to 4 in this example. So it should be apparent, sorry, not appear, it should be apparent. Apparent that A is equal to C1 union C2 union C3 and union C4. So this what we look here. Now this was the theorem. So based on this theorem, let's consider an example here. Now this example says that if you remember in the coin tossing experiment, that we experiment of example that we discussed 1.9, that experiment actually, if you remember, we have 4 coins. Okay, now in that experiment, let A is an event equal the set of outcomes with the less than with less than 3 heads. Now in that case, this capital A actually equal to this one, this outcome, this outcome, this outcome. Similarly, this outcome, also this one, then 2 heads 1, then combination of this one, then also that combination, this combination, this combination, and lastly this combination. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Outcomes here in this event. Now if we look at from example 10, we defined an event space with Bi actually is equal to outcomes with ith head. So we define B space as B0, B1, B2, B3 and B4. So this is actually an event space Now if we use the theorem, that is the 1.2, if we take use theorem and we take the intersection, we can rewrite event A as actually A intersection B naught union A intersection B1 union A intersection B2 union A intersection B3 and union A intersection B4. So this is the result we are getting, and we know that actually BIs is actually for all BIs A is actually a subset of, but subset of for I is from 0, 1, 2, because event A is basically depends upon, if you look at, equal the set of outcomes with less than 3 at. So these more than 3 become 0, it don't have any element in it, so it left with only 3. So in other words, if I can write as this actually an event of A intersection of B naught union A intersection B1 union A intersection B2. So in that case is, because these are the subsets of A, so this means that this become B naught union B1 union B3. So they make up the event A. Okay. So this what we, when we apply the what you say, the theorem 1.2 in our example. Now let's see if we look at if we do a quiz here, okay. So this is a quiz. Okay. So this is a quiz number 1.2 in your book. Now what quiz says that? It says that monitor 3 consecutive phone calls. So through telephone switch. Now we have to actually observe these calls to telephone switching office. So if we classify these 3 calls as voice call. For voice call we use terminology V, data call. For data call we use a symbol data call carrying modem or fax signals, okay, carrying or fax signals represented by D. So there are 3 actually calls. So first call can be a data call or a voice call. Similarly, second call can be a data call or a voice call. So there are 3 in numbers. Now for this quiz, if I write the first question asked is that you have to write an event A1 that is equal to that first call. First call is a voice call. Now, as I told you that the first step to solve this type of problem is to write a sample space. Now, let me write a sample space SS because there are three calls. Let's assume that all three are voice calls, or two are voice and third is data voice, voice, or voice data call, or we can say that data voice data call, data voice call. Okay, or we can write as three all the data calls. So let's 1 2 3 4 5 6 7 8. So these are 8 outcomes. Now for first case, so if I have to write the answer here, first call is a voice call. Now this is the one, so I can choose the first outcome because first call is voice. Again I can choose the second one because first call is a voice. Similar, I could choose the third one, and also not the fourth but the fifth one outcome. So there are 4 outcomes which shows that we have the first voice call. Now let's go to the next question in the quiz, and he is asking A2. Now what is A2? He says that second call is a voice call. Now again this is very easy. So for second call is a voice call. So this means that first call can be voice, second call can be voice, and third call can be a voice call. So again we can write that first call is a voice call, second call is a voice call, third call is a not a voice call. Or we can write that first call is a data call, second call is a voice call, last call is also a voice call. Or first call is a data call, second call is a voice call, third call is a data call. So these are the possibilities, that these are the outcomes in this scenario. If we go to the third one, A3, so A3 says that all calls are the same. So there are 2 possibilities, or either 3 are voice call or 3 are data. And now fourth question says that B1. B1 is again first call is a data call. Now first call is a data call, so this means that data call, voice call, data call, voice call, data call, data call, voice call, data call, and data call. So this is a possibility. Again in fifth says second call is a data call. So again in this case, second call is a data call, so this means that first call can be voice call, data call, voice call, or voice call, data call, or data call, voice call, or data call. So this is the outcome. If we look at the last one, sixth one says that already 4, 5, 6. Sixth one says that voice and data alternative. voice and data alternative. So in that case, voice data voice, data voice data possibilities. Now last one is before it says two or more data calls. Two or more data calls. So we can have voice call, data call, data call. We can have data call, voice call, data call. We can have data call, voice call. We can have 3 data calls. So this way you can easily look at. Now what we have to do is here, for each pair of events, PI, identify whether pair of element events is either mutually exclusive or collectively exhaustive, or both. So what we have to do, we have to check for mutually exclusive that equal to empty set, and collectively exhaustive means that equal to sample space. So this is what we have to find. Now if we look at B1 and A1, so if I go back, this is A1. Okay, now if I this is my A1 here. So what I have to do is if I can copy as a text, I go to next slide. Okay. It's not copying. It's okay if we rewrite here instead of doing this. First call is a voice call, so in that case VVV, VVD, VDV, then VDD, then that's it. Now if you look at, this is the first one, A1 and B1. So do you find any common element in it? I don't think so. So this means that A1 section B1 is equal to integer. So this means that A1 B1 are mutually exclusive. Now what about collectively exhaustive? So if I take A1 union B1 and see it is equal to S. Now if I take A1 union B1, so it's not equal to S. So they are not collectively exhaustive. Okay. So they are mutually exclusive but not collectively exhaustive. So this way you can check all the pairs available in this case. Now I stop here for first part of this video lecture.